Alright, so welcome to part 2 of building the robotic arm. Next we're going to start by making some of the models that are going to go on top of our rotating base and provide the linkage between the base and the gripper. So this first model that we are going to do here is for the kind of arm supports. So this is going to be our servo motors that you raise and lower the arm. And so let's just go ahead and get started. So first thing I'm going to do is we're going to just draw a line that is 46 millimeters, and then I want to put a constraint with this triangle, which is our midpoint constraint. That I want the line to lie on the middle of the origin, so it's perfectly symmetric on each side. If we continue drawing our shape, I'll have our line tool that goes up 8 millimeter and then over 5. Perfect. We will just copy that over here. So up 8, press L for line, over 5. Oh, 0 degree, straight line. Wonderful. That should be 8. I don't know why it's done that. Looks like let me just delete the measurements here since we've got them all sorts of messed up. This here should be 5. And this should be 8. Perfect. So now, for our geometry, it looks like all these continuing lines will eventually be tangential to these construction circles that we'll add in. We could do a couple more lines on the right side here. So we will have a line that goes from this point here all the way into, why is this? 1 second. I want to back this up. And redraw that just to make sure, since I saw it was a blue line fixture. Let's just make sure. Perfect. Now we can continue drawing our lines over here. So we have a line that is going to go up at an angle. This angle is 13.85 millimeter in length. And the angle from the back side is 140, so that means that this angle right here must be 40. And then we choose our line, and we go straight up from here, a distance of 19 millimeter. Wonderful. So now let's go ahead and add our construction circles. So the one I'm talking about in our figure is this blue circle here, and also we have one not highlighted up here, but we have dimensions for it. We have, for our first circle here, 45.75 millimeter diameter. So I will just add that in, 45.75. And for our spacing, the distance from the bottom of the model to our center point is 57.58 millimeter. Wonderful. And then the distance from the origin, put that there, is 20.22. So now that is correctly placed. We have one more circle up here that has a radius of 6.79. So 6.79 times 2, so we get into a diameter. We're going to say the distance from our origin to here is 81.5 hit enter, and then if we get our horizontal spacing, like so, we see that it is 14.5. Wonderful. So now what we can do is I'm going to do our line tool, select this option right here, and if we go along our circle, you'll see it appear here. The little circle, smaller circle, that means it is now tangent to that point. So instead of using the tangent constraint, it'll do it for us. As for up here, I will just click here and drag until I get the tangent constraint. I will say I want this line to also be tangent with the circle here. That'll do it just for us. And finally, we will go from this point until we are tangent on this circle. Perfect. We're going to hit E to extrude everything, and our thickness is 5 millimeter. And that's our first shape right there. Alright, we have a couple more things left to do. We won't get too fancy like this drawing file here. We should mount our servo next. So I'm going to draw a sketch on the place here. And so we see, based off of the drawing file, that our servo lies on the circle that we drew earlier. So what I'm going to do is I'm going to draw a line, and I'm going to find the center point of our circle in here. So if we just hover around, there we go. We'll find the center point. I'm going to draw a line, and we see that our servo is rotated to be at a 35-degree angle. So I'm not going to specify the width. The length is not as important of a detail. Actually, we can use it. I see now that we have a 6 millimeter gap from the center to the edge, so I will make that 6 millimeters. And then our angle would be 35, so I can do 180 minus 35. Place that here. Let's go ahead and make that a construction line. Now we can draw our servo. So let us draw a line so we know from here to here where it's perfectly parallel. We see that should be 12. We're at the halfway point, so I can do 6 that way and another 6 that way. We'll go out to 23, hit enter. Another line. This time we can go up 12. And now we will complete the geometry. So that's perfect. I'll go ahead and delete that construction line for now, because I am going to opt for extruding out the mounting holes that we need, and then just threading them later, since we've already got the geometries drawn here pretty well. So we see that we have our circles from the midpoint. I'll actually just draw a construction line, just like so, out. Construction, we will attach our M2 mounting hole to that. We'll come down here and do another one. Perfect. And then let me zoom in and make that a construction. So I'm going to go ahead and put a equals constraint that says I want the distance between these 2 points to be equal. Already there. So they're equal. We can double sanity check. 2.101. Dimension here. 2.101. Perfect. And then we know that the overall distance between these two from earlier should be 28 millimeter. Equally spaced. We can also see from our drawing file, if we wanted to space these lines out without using constraints, we would see they should be 2.5 as drawn there. So I'm going to hit E, select all our points, and we're going to go -5 millimeter. So if we go to our Create tab up here, we have the thread option. So we can zoom in, rotate slightly, and pick all of these. I'm going to pick M2, hit OK. Thread this to be M2. Wonderful. So finally, we need to put some mounting holes to affix this to our arm mounting base. So finally, we will do a sketch. We will go down into here. Make that an M3. And then as earlier, when we did our mounting base, we know the distance here should be 4 millimeter. And the distance between these points should then be 3 millimeter. And then I will do the same thing on the other side. 3. Let's do our spacing to be 4. I'm going to press the H key for the whole command. Choose these to be M3s all the way through. And with that, that will be the arm support that we'll need. Whenever we go to print this, we're going to want 2 of these.
Alright, moving right along, we have our next part, and this is going to be the arm bar. Now, this drawing file implies that we're going to have some curvature, but I don't really think that is necessary for our basic robotic arm. So, we're going to use its dimensions, but we're not going to worry about curvature. We're just going to keep it in line with our axes. So, I start a sketch. This one will go by fairly quick since I think we're pretty well equipped to model most of these parts now. So 17.5, that's a radius, so times 2. We have another circle located up here. It's 15 diameter. And we could draw tangent lines. And just make sure everything is perfectly tangent. I want to make sure that that is tangent to there, and then this will already be done for us because I used the quick tool. Alright, and with that we can extrude to 3 millimeter. We will draw a sketch. Now all we have left is our mounting holes. So we have one directly at the origin, diameter of 8. And then we have our M3 mounting holes is what I'm going to call it. Spaced up along here. And we have, 3. Perfect. And then our last one is directly on the origin of that last circle. Now we have some spacing requirements. So we want these two to be at least 50 millimeter apart. And these two to be 50 millimeter apart. And I just realized I forgot to specify the distance on our arm. So we just gave it an arbitrary length, but that's okay. So I'm just going to go back into edit the sketch, and we want to say distance between here. On this document it reads at 148. Since we have 3 equally spaced mounting holes at 50, I'm going to opt for 150 millimeter. We'll finish our sketch. That'll update our part for us, and then we can extrude
all of these, -3, and then we can use our thread tool. Where is thread? Thread, there we go. Zoom in. This is M3. Perfect. And our last one. Now finally we need to make our mounting architecture to where the servo spindle will attach to our arm. So we'll do this. You can go back and look, but if you recall, our mounting holes for the spindle were on a 14 millimeter diameter construction circle. And then here, these are just perfectly on our axes. And this is an M2, since it is for our servo. Circular pattern. Save us some time. 4. I'm going to hit OK. Press the H key. Select all of these, and we're just going to make sure that we have M2. Hit OK. And that should be our arm bar. So I'm going to go ahead and save this and show it because there's a point to be made here. I'm going to call this our arm bar. Hit save. So when I go into here for our thing, you'll see up here we have 10 out of 10. So if you're using the free version of this software, we've reached the limit of 10 editable documents. But that's okay, we can get around it. We know we don't want to change any of these other components at the moment, so we just click on here and start making components read only. You can uncheck this at any time, so you can make any part editable at any time, just as long as you have space. So since we have already designed these, we do not need this to be editable anymore. I'll leave the assembly for now and our arm pieces. So now we have 3 out of 10 documents. Alright, we're going to move on to our next component. Let me just close the data pane and we'll get started. Everyone should be pretty familiar on drawing parts like this. The only thing missing from our drawing file is the diameter of the smaller circle, but that should be 8 millimeter. Extrude 3.65. Create our sketch. Our mounting holes lie on a 14 millimeter diameter. And this is what connects to our servo. So these are M2s. Now what am I doing? Circular pattern. Press H for the hole command. M2. And that is our spacer. Alright, so let's go ahead and start our next component. Let me save this as spacer. Start a new design. And this is going to be the axle or shaft that the arm fixture could rotate around, which is pretty straightforward. For this arm design, I'm going to be changing the dimensions. So we start here. We have ourselves a 8 millimeter diameter circle. We zoom in. That we just extrude. For us, this will be 29 millimeter.
And then you'll see that we have what is known as a chamfer on each end of this. So to do a chamfer, we go to modify, chamfer, and we want to pick the edge. I'm going to say for now we can just do equal distance. So we can click there and there. And for this, I like to do 0.5 millimeter. And then it'll do a very nice edge for us. And so that is the shaft. Alright, and the final part we need kind of for the linkage between the rotating base and the gripper is a spacer that will go along the arm bars right here. So let's quickly start our sketch for a 6 millimeter diameter. We're going to extrude it. In our case, this will be 23 millimeter. We'll hit OK. And then we have another 0.5 millimeter chamfer that we can add. Right here. Perfect. Finally, we have ourselves an M3 mounting hole. So we could do a circle, 3, press H for the hole tool, select it. We'll change this to M3, and this goes all the way through our component. So 23. And then we can save this as our arm spacer. Alright, so now it's time to assemble all of our parts together. So we'll get started. I've went online and found a CAD model for our 9-gram micro servos. If you go online to grab CAD, you can find several of these and download them. I think this will really help with the assembly, so I'm going to insert it in. Move it up. You'll want to double check that all these things are modeled perfectly. I know this model has some where it attached to the spindles disconnect from the body, but that is okay. I'm going to do that. It is in the wrong place, so we're going to flip it. That looks to be really good. And then now we can join our face back to here. Click the flip button if that happens. And now we can rotate, do top. And we see our mounticles are lined up. So we hit OK, and wonderful. So that is placed our servo motor there. So now let's add in the other pieces. Let's add in our arm supports. Move that over. We're going to rotate J there to there. Perfect fit. Let's do our second arm support. This way, making sure that they are still kept aligned. Perfect. Flush. And those are lined up. I'm going to go ahead and insert 2 more servo motors into this. Drag that out. And first I want to align in this situation the mounting holes. Make sure that should be right about there. That's pretty good.
Hit OK. We now need to reattach our piece here. And then adjust it so it's flush like it normally would be. That's perfect. So from this servo, let's go ahead and just, I guess, put in our next one. Awesome. Same as before. Join our mounting holes. It's backwards, so I'm going to flip it and rotate until we get both. Hit OK. That'll move it. Now we just need to get you back there. Rotate. I'm going to slide it in, make our adjustments. That looks really good right there. So now our servos are placed. From that, we would have our servo spindle for each one. Okay. And I want to join that to there. Rotate, and then we know that this should fit flush that another servo spindle into this. And let's do the same thing. How'd that do? That did pretty good. So we have that right there. Next, we are going to have our, where's our spacer? Each one of these is going to need a slight spacer to get this dimension properly. I'm going to join this top one to this point here. Let's rotate. How's that look? Looks great. Now we have our arm bar that I can draw out just like that. Oops, hit J. I want that mounted to here. And then let's flip it. So yeah, then we'll need to do our rotation. Like I said, we're just making sure everything's aligning up properly. And that looks great. Hit OK. Amazing. Let's go ahead and do the other side as well. So we'll have another spacer come in. I will say you can go right there. Rotate to where it's kind of hard to see, but that is close. Hold on. I'm going to hit escape. I want to redo that. That just seems to be giving some issues. That can mount. Maybe it should go here. There we go. That's better. Arm bar for the other side. We're going to flip and rotate, make sure that that all is lining up properly. There we go. That looks to be really good to me for right now. Amazing. And so now we would have our shaft for this to rotate upon. We would hit join. This is going to affix to that, and then we're going to have to do some adjustments because this isn't perfect. Just about right there. It's really, really nice. So that is going to be what the arm rotates on. And then finally, to add structural support, we have our arm spacers. And we'll have 2 of those. So let's put that into that. That looks really good to me. We'll hit OK. And then 1 more arm spacer for completeness. Go ahead and add it in. Wonderful. And that will go right there. And then hit OK. And we leave this last one open because that is where we're going to hook the arm's gripper into. So at this point, this is what our robotic arm will look like. We'll have 1 servo rotating the base. In this design, we have 2 servos, but they are doing the same function. So you can wire this to the same joystick input, since these servos will do the same thing. And so next and final steps that we're going to need to do is we're going to need to design a gripper that can hook into the top part of our arm up here, and I'll have our last servo motor that we will need to get the gripper to open and close, and then that should be all the parts. So let's move on to the gripper. Alright, so for our robotic arm gripper, I'm going to first make a little servo motor mount. This is for our 9-gram servos we've been using. So I'll create a sketch. I'm going to want to do a center rectangle. And we're going to model this to mount a micro servo to. So I'm going to say 32 by 12 because that's the dimensions of the total size. Press E to extrude. We'll go up 5 millimeters. Create a sketch. We're going to say this top right, it should be 4.5 millimeters for that, and we'll do 6. Take up half the object for right now. Make another one on the other side. Extrude that up. 12 millimeter. Oops, forgot. 12. Now we can create a sketch of this face. We're going to hit the P key for projection, so we can project this face and do drawings on it. Hit OK. We're going to take a circle and we're just going to find the midpoint here. Draw our M2 circle. Same thing over here. 2. Press the H key for a hole. And we are going to make sure that's M2 all the way through. Alright. So as a sanity check, I'm going to insert our servo motor model into the design just to make sure right now that this fits properly. Hit J for join, just like that. Let's rotate it up. There's 90 degrees. That fits. That's slightly off, which is unfortunate. But I think that's just due to our model. It looks pretty good from this side. Hangs over. So I'm going to hit escape and undo that because we don't need that for right now. Just wanted to make sure that looked good. We're going to create another sketch because we want to have it not hanging off, and we have to be able to mount this to our arm linkage. So I'm going to use the line tool so we could do some constraints. Draw our rectangle out and hope it connects. Alright, so we're going to hit dimension. Or actually, before we dimension, we're going to say that this line and this line should be equal. There we go. So that centers our rectangle on this point. I'm going to dimension this. I'll say we go about 15 millimeter out. And I want to dimension this to be 23 because that's the width of the servo, not including the little wings for mounting. I'm going to hit E, select this space to extrude, -5. Down to there. And finally, we'll do a sketch on this face right here. Circle from the midpoint for our M3. I will dimension the center point from this line to be 3 millimeter. And then we're going to press the H key. Make sure that we have M3 selected. And for this, I'm just going to go the whole way through. So this will mount to our arm linkage, and then this is our little 9-gram servo mount. Alright, and to finish off this guide, I think it's important to kind of show ways to find different prints. One really good site is Thingiverse. If you check it out, you can search up lots of different STLs that people have made, download the files to print yourself. This goes to show you can use whichever gripper design that you would like for the arm. I'm going to choose this one just to keep it really simple, a nice rack and pinion style robotic arm gripper. There's lots of different complicated ones out there. If you would like to try to find those and model them yourself, I highly encourage you to do it, but for the sake of time, and to highlight that you can find STLs for robotic arms and various different things all online, we can use Thingiverse. So I've just got a simple 3D printed 9-gram servo gripper. It is a rack and pinion, so as the gear rotates, it moves the rack back and forth to grab our objects. So most parts will have a video showcasing how it works. In summary, it'll have all the files that you need to print with it, so you can download. These are already STLs, so they are just ready to print. And so we can print that. I'll post the link in a little text block that you can go see it up in the top right corner. And finally, since we've done this up until this point, I want to make sure that we show that our servo mount, if I insert it into our assembly we've been using this entire time, join that part to there. I'm going to flip it, and then I'm going to do a rotation at a slight angle, just for me, make sure that lines up, and we hit OK, and then we'll use washers and M3 bolts to secure it. And then if you use the rack and pinion style gripper, this should mount directly to it. If you have another gripper style, you may have to model your STL files, but in summary, here is our robotic arm, where most of it is designed by us. Some of it is using resources online. I think it's really cool to use both to develop your 3D prints. And this hopefully should be 3D printer ready and friendly to use. So thanks everyone for checking out this video, and I will see you next time.